Looks light, right? Wrong. A single cumulus cloud, one of those fluffy white ones, can weigh over 1 million pounds. That's because it's made of tiny water droplets, or ice crystals spread over a huge area. Heavy stuff? Follow for more. Nope, not a chance. It might look like a big fluffy white cloud floating lazily through the sky, but don't be fooled by its seemingly weightless appearance. One single cumulus cloud can actually weigh millions of pounds, and that's just its weight on Earth. Space, it could weigh even more. Now, you're probably wondering how something that looks so light and airy can possibly weigh so much. Well, it all has to do with the size and composition of these clouds. Cumulus clouds are typically made up of tiny water droplets or ice crystals that are suspended in the atmosphere. These droplets or crystals are incredibly small, often just a few microns in diameter. However, they are spread out over a vast area. A single cumulus cloud can span hundreds of square miles and contain billions of these tiny particles. The sheer number of them is what gives the cloud its impressive weight. But that's not all. These clouds also have a significant vertical extent. They can reach heights of several thousand feet, meaning they have a large volume in which to accumulate mass. Additionally, the particles within the cloud are not evenly distributed, tend to be more densely packed in certain areas, leading to heavier sections within the cloud. This uneven distribution of mass can result in some interesting cloud formations, such as the towering vertical structures known as cumulonimbus clouds, which can produce heavy rainfall, strong winds, and even hailstorms. Now let's talk about the weight of these clouds. As we mentioned earlier, a single cumulus cloud can weigh millions of pounds. But how did we come up with that estimate? Well, it's based on a number of factors, including the density of the cloud, its height, and its horizontal extent. The density of a cloud refers to how closely packed the water droplets or ice crystals are within a given volume. The higher the density, the more massive the cloud. Cumulus clouds typically have a density range of 1 to 5 grams per cubic meter. Let's take an average density of 3 grams per cubic meter for our example. Next, consider the height of the cloud. As mentioned earlier, cumulus clouds can reach heights of several thousand feet. For the sake of simplicity, let's assume a cloud height of 2,000 feet or 600 meters. Finally, we need to look at the horizontal extent of the cloud. Cumulus clouds can span hundreds of square miles. But for this example, let's assume a more modest size of 1 mile, or 1.6 kilometers in diameter. With these dimensions, we can calculate the volume of the cloud using the formula for the volume of a cylinder. Volume equals pi times radius squared times height. Plugging in our values, we get a volume of approximately 7.85 million cubic meters. Now we can calculate the mass of the cloud by multiplying its volume by its density. Mass equals density times volume. Using our assumed values of 3 grams per cubic meter and 7.85 million cubic meters, we get a mass of 23.5 million grams. To convert this to pounds, we divide by 453.6, since there are 453.6 grams in a pound. This gives us a mass of approximately 52,000 pounds. So there you have it. A single cumulus cloud can weigh over 52,000 pounds. Now that you know how heavy these clouds can be, you'll never look up at the sky in quite the same way again. But that's not all there is to know about clouds. There are many other amazing facts that will blow your mind, so keep watching to learn more. Clouds come in all shapes and sizes, from the wispy cirrus clouds high in the troposphere to the towering cumulonimbus clouds that produce thunderstorms. But have you ever wondered what gives clouds their different shapes? Cloud formation is a complex process that involves a variety of factors, including temperature, humidity, and air pressure. When warm water vapor in the atmosphere condenses into liquid droplets or ice crystals, it forms clouds. The shape of the cloud depends on a number of factors, including the temperature, humidity, and air pressure at different altitudes. For example, cirrus clouds are high-altitude clouds that are made of ice crystals. They often have a wispy or feathery appearance due to the way the ice crystals form and interact with the wind. On the other hand, cumulus clouds are low-altitude clouds that are made of water droplets. They typically have a puffy or heap-like appearance due to the rising air currents that form them. The different shapes of clouds are not only visually appealing, but also provide valuable information about the weather. Meteorologists use cloud observation, along with other data, to forecast things like precipitation, wind, and temperature. One of the most fascinating aspects of clouds is their ability to produce precipitation. When water droplets or ice crystals in a cloud become too heavy, they fall to the ground as precipitation. The type of precipitation, whether it's rain, snow, sleet, or hail, depends on the temperature of the air through which the droplets or crystals fall. Clouds can also produce other forms of precipitation, such as fog, which occurs when water vapor condenses near the ground, reducing visibility. Understanding the processes that form clouds and produce precipitation is essential for weather forecasting and climate modeling. But that's not all. Clouds play a crucial role in regulating the Earth's climate, as they reflect and absorb solar radiation, helping to cool the Earth's surface. Clouds also trap heat in the atmosphere, contributing to the greenhouse effect. The amount of cloud cover and the altitude of clouds are key factors in determining the Earth's S&G balance. Clouds also influence regional climates by transporting moisture and affecting local temperatures. For example, coastal areas tend to have more cloudy days and moderate temperatures compared to inland areas. Understanding the role of clouds in the climate system is essential for predicting future climate change and its impacts. Clouds are truly fascinating natural phenomena that play a vital role in our planet's weather and climate. Their ability to form in a variety of shapes and sizes and produce a wide range of precipitation is a testament to the complexity and wonder of the natural world. Whether you're a weather enthusiast or just someone who appreciates the beauty of nature, I encourage you to keep learning about clouds and the many ways they shape our world. If you want to know more about clouds, check out this video. Now, it's time to test your knowledge with a quiz. How heavy can a cumulus cloud get? A. 52,000 pounds. B. 1 million pounds. C. 23,500 pounds. D. 453.6 pounds. The correct answer is A. 52,000 pounds. How do clouds get their different shapes? The temperature, humidity, and air pressure. B. The type of precipitation. C. The altitude of the clouds. D. All of the above. Correct answer is D. All of the above. What is the approximate density of a cumulus cloud? A. 1 to 5 grams per cubic meter. B. 7.85 million grams per cubic meter. C. 453.6 grams per cubic meter. D. 23.5 million grams per cubic meter. The correct answer is A. 1 to 5 grams per cubic meter. Which type of cloud is made of ice crystals? A. Stratus clouds. B. Cumulus clouds. C. Cirrus clouds. D. Nimbus clouds. The correct answer is C. Cirrus clouds. Thanks for watching. If you enjoyed this video, please hit the like button and subscribe for more fun science videos. See you next time.